Hi, Ken Goodman here. I'm an electronics nerd from way back, and oddly enough, one of the things I like to do for fun sometimes is take apart old electronic devices that failed and find out exactly what went wrong inside. Today, I want to share with you a teardown I did over the recent holidays of a couple of Philips LED light bulbs. I'm a big fan of LED lighting, and I bought these two bulbs, I think about the same time, several years ago. And one of them failed a couple of years ago, and one of them failed recently just before Christmas. I've been wanting to tear the first one apart for quite some time, and now I had two, so thought it was a good time to tear into them. It turns out both of these bulbs failed in the same way. Each bulb has three ceramic circuit boards carrying the LEDs themselves, and flying leads are soldered to surface mount pads at one end of the board. Those leads connect to the switching power supply through this splitter board at the tip, and of course all that's inside the housing and heatsink. Both bulbs had solder joint failures right here where the flying leads attach. And looking at those solder joints under the microscope, it looks like these boards actually got hot enough to begin to melt the solder on those pads. I say that because of the way the solder is starting to bong up on top of the pad. And I'll insert some photographs I took through the microscope. Naturally, when I took the first bulb apart, I had to completely tear it apart to see how it was all put together before I really stopped to think about what might have gone wrong. So I spent way too many hours picking potting compound out of here, and also destroyed some of the components getting everything apart. The second bulb fared a little better because after seeing the failed solder joints here, I decided I could just pop these covers off, check the LED boards, and perhaps even repair it. And after seeing the failed solder joints there, I actually repaired the LED carrier boards and put the bulb back together and lit it up again to prove that everything else still worked. These are fairly expensive bulbs. Of course, they've all gotten cheaper from a lot of different manufacturers over the last several years. These things are built like a tank, although it didn't help these two particular bulbs because of the weak link here. So let me talk about how it's all put together. You can see the AC power comes in through the tip. There's a couple of leads inside here that are soldered to the tip and then soldered to the switching power supply board inside. This housing doubles as a heatsink. I'm guessing that's an aluminum alloy of some sort. The switching supply goes inside there. There's potting compound surrounding the switching supply that helps conduct heat away from the components here, although what really gets hot, of course, is the LEDs themselves. The output of the switching supply comes through a 2-pin header onto this little splitter board, this little 3-way splitter board, and then goes to the 3 individual circuit boards carrying the LEDs. Okay, those circuit boards are, of course, attached to this heatsink like so, and the ceramic board, the ceramic substrate, carries most of the heat from the LEDs through this insulator pad to the heatsink itself, where most of the heat's hopefully radiated away from the bulb. Of course, inside a fixture, things can still get pretty hot. The LEDs on this particular product are blue LEDs. And so these covers are molded with a yellow phosphor embedded in the plastic. Most of the blue light is absorbed by the phosphors and turned into yellow light, which mixes with the remaining blue and gives you a nice broad spectrum, so that the result is a fairly pleasing white light. As I mentioned before, on the second bulb, I was very careful taking the covers apart, and I didn't tear into the potting compound and switching supply and all that, so I was able to repair the failed solder joints and reassemble the bulb and light it up. So just to show you that it works, here goes. Boom. So there you have it. Those two Philips LED bulbs both failed because of the solder joints probably starting to reflow on the ceramic LED carrier boards. Maybe that could be improved by tack welding the flying leads, or using a higher temperature solder on the flying leads. But of course, since those bulbs were designed and manufactured, there have been a lot of changes in LED bulb construction, and a lot of the cost has been taken out. And after all that, I hope someone besides myself gets some enjoyment or maybe a little education out of this video. Good day.